Okay, so we're going to look at finding the residues of this function here at its simple poles using both simple pole methods. So first we use the direct method. So, okay, direct method, I'll call method A, is let's do the z equals minus 1 first. So we just multiply phi by z minus z0, which in this case is z plus 1, and evaluate at z equals minus 1. So the residue of phi at z equals minus 1 is, I multiply this by z plus 1 and just end up with z over 2z minus 1, which I evaluate at z equals minus 1. And that gives me minus 1 over minus 3, which is 1/3. Now for the other one, z equals half. This time I multiply by z minus a half. I can't just make this thing disappear this time. I'm multiplying the top by z minus a half, which means that I've still got a factor of 2. So that's the thing which you have to be careful about with this direct method. So I end up with 2 times z plus 1 left over on the bottom. So this 2 comes from, I'm multiplying by z minus a half, and I can only cancel this if I take out a factor of 2, then I got z minus a half. Okay, so that's where the factor of 2 comes from. So this, if I evaluate it, z equals a half, so that gives me 1/2 divided by 2 times 3/2, which is 3, which is 1/6. Okay, so let's now use the other method, called method B, the P over Q dashed method. So the thing is, okay, so we do the z equals minus 1 case. You can choose P to be anything as long as P is not 0 at z equals minus 1. So and normally it's basically the best choice is to make Q as simple as possible, since you're going to differentiate it. So the obvious choice for Q in this case is this thing here. So we make Q z plus 1. So when I differentiate z plus 1, I just get 1. So what the answer is P, and Q dashed is 1. So I just get this, which I evaluate at z equals minus 1, and I get minus 1 over minus 3 again, which is 1/3. So it's pretty much the same as the direct method, the first method. Now for the z equals a half case, this maybe is slightly simpler. Now I'm going to choose Q to be this thing, and I just differentiate it. I get my factor of 2 again, and it's the same as before. I get half over 3, which is 1/6. So in this particular case, there's not much difference between the two methods.